So the subtitle of your book is An Iterative Process for Production Ready Applications. Could you parse that out for our listeners? What is a production ready application? How important is iteration? Yeah, tell us
I
about
I think it's
these
funny you
things.
use the word of parse because I feel like it's a very software engineering term. I don't think normal do people outside tech use the word
I
parse
think it's
like that?
technically correct, though
Yeah.
probably not as widely used
Yeah,
outside of
I
software engineering.
see. No, that's funny. So, I'm gonna be like absolutely honest here. I dream of the day when the phrase "production ready" will become redundant. So we don't say something like "eating ready food," right? Like, what is the point of like making food if it's not ready to be eaten, right? So I feel
Right.
like, sorry, I'm a big fan of food. So, all my metaphors are related. I think even our company's name, like Claypot, is inspired by food. So I think like production ready applications, I feel like if you build an application, it should be production ready by default. And the reason it's necessary nowadays still is because a lot of people still not think about productions when they build machine learning models or doing experiment. So for example, maybe things have changed over time, but I would say like when I was interning at Netflix, so people have heard about Netflix price, right? I was very eager, so I came as an intern and I went to the director of algorithm and was like, so how is that the winning solutions doing, because it seems so glamorous, we did so great. And he was like, we never actually deployed it. And the reason is that it's very hard to deploy because it was an ensemble algorithms, and even though it could edge out really good performance on like a leaderboard, leadership board, no, with leaderboard starring
Yeah,
competitions.
leaderboard.
It's too much leadership talk. It's not really easy to bring to production. So that was my first lessons, and as I always saw a lot more of it, so first of all, like another is that like models can be brought to production, but they just don't stay in production for very long. So one classic example that I've seen a lot is that like a company would bring out on a consultant to have them build a ML models, and they take like maybe 6 months to build and a few more months to deploy, and it works great in the beginning, but after a few months it just doesn't work anymore. It's because things have changed, and now the company have like the environments, business requirement have changed. So for example, like that company might be a say supermarket, and they might bring on someone to build a model to predict inventory, like inventory management. So after a few months, after a year in production, is a model like we have a lot of new items, right? That what people want to buy have changed over time because trends in the market. So the models just don't predict correctly anymore. So now the like supermarket has like several options, right? You can either bring in the same consulting firm, like and pay them a lot extra money, or you can just like build something like from so in-house from scratch. So I think that's a painful lesson that a lot of companies have experienced. So when we do things about like building a model, so you think about like first whether they can be deployed, and second like how to make it like continually work in production. So that's where the iterative comes from.
Cool. That was a really great explanation, and I love the analogy to food. It's such a crystal clear way to describe it. To say, people don't spend time in the kitchen 80% of the time to then
Yeah,
throw out the food, but
yeah.
that's what happens in machine learning. Is something like 80% of the time, machine learning models are created, or at least a machine learning project is started, and it doesn't make it into production. Nobody gets to eat the model.
So I think I would like challenge on the statistics because it's very hard thing to measure, right? Because like
Right.
the nature of machine learning um, is experimentation. So just experiment with a lot of models. So it's by nature, so a lot of them are not gonna make it to production because you probably want to deploy the best one, not all of them.
Right.
Yeah,
That's a good point.
yeah,
So I guess it's kind of like, yeah, I guess because a way that the food analogy is quite different is that typically, like, we're making the food one meal at a time,
yeah,
and we only spend like an hour preparing dinner. Whereas
yeah,
with a machine learning model, you might spend months or years in some cases, and
yeah,
then so you don't want
yeah.
to you want to make sure that that was time well spent, especially if you have different competing options for your machine learning solution.
Yeah, you want to like so I think that for a lot of companies like machine learning is a tool. I think it is a tool, right? And when you invest to a tool, you want to see return out of it. So like if like doesn't matter like how fancy the model is, if you can't really show concrete returns on business, I don't think you're not gonna get promoted. You're not gonna in a lot of cases we see that companies invest a lot in machine learning and then they just don't really get good returns and the whole team just get laid off. I think a very painful lesson is like zero estimates, estimates, right? I think are you
Mhm.
familiar with a
Oh,
case
yeah.
study?
Oh,
Yeah.
yeah.
So I'm not gonna recap. So I think like they did have a competition similar to Netflix price. So it was like
Mhm.
$1 million winning prize, and they did a lot of marketing campaign on it. And it's like, okay, now we're like using the state of the art to like predict housing price really well. And a year later, they reported a loss of like $800 million, and they just like laid off, I think, the entire Zillow offers team or something like that of like 2,000 people.
Yeah, I guess that kind of problem. I don't know the problem super well, but you might know better than me. Perhaps some of the issue was feature drift, where the
Yeah,
world changes. So the model works perfectly on historical data, but
yeah,
then something like the COVID pandemic
yeah,
happens, and the factors that are driving house prices completely change, but you
yeah.
still got the same model weights pre-pandemic.
Yeah, so that's very important, like to make the model like adaptive to the changing environment, right? So you need to constantly iterate on the model so you think change. I think COVID is one of the extreme examples, but I think like there are a lot of things that can affect a model performance in production. It's just like trends go over time, so competitors launch a new marketing campaign, or you yourself launch a new market, or it's just because of things that change over time.
Yeah, the world is always changing. And our machine learning models aren't necessarily always learning and adapting, though I suspect a
Yeah.
big part of your designing machine learning systems is to have our machine learning models continuously adapting.
Yeah, and I
Um,
think like it's I feel like for every applications the rate of change is on a different, right? Like some applications they're gonna change very fast, but some applications gonna change a lot faster. So I do think it's like one important thing is like to measure like if you delay updating the models and how much performance hit you're gonna get. So say like Facebook early days, like in the maybe like 10 years ago, internet didn't move quite fast, right? So they did run some experiments and they found out that for their model as click-through predictions, if they had something like a delay model update by like a week, it caused some significant performance hit compared to like updating the model every day. So they chose to move update to every day. But like it was 10 years ago. But nowadays the world moves even faster. So we've seen some experiments people was found out as like so LinkedIn, they found out that like the model, the features staleness just go from like an hour compared to a minute would reduce their performance by 3 point something percent for their recommender system. So I think like the rate of change very depends on applications, very depends on where you are, what industry you're in.